So very similar to what we just did in 8.2, we are just taking it one step further with slightly more complex functions. So once again, the first thing I would always do in graphing a rational function is I would rewrite it in terms of exponentials and degrees. So since I have a constant here, I would rewrite 4 as 4x to the 0 power over x squared plus 2. This will help in my process of finding my horizontal asymptote. Once I'm here, let's find the vertical asymptote. So in order to find the vertical asymptote, we are asking us what x value would cause our denominator to equal 0. So algebraically, this can be written as x squared plus 2 equals 0. Let's figure out what x has to equal in order for the function to equal 0, or our denominator. So subtract 2 over, give me x squared equals negative 2, which, as we know, if I was to take the square root of this, it's going to give me an imaginary number. So in this case, I don't have a vertical asymptote, which is just fine. For my horizontal asymptote, this is where we refer to our chart. The degree of my numerator is less than the degree of my denominator. So that tells me that my horizontal asymptote is at y equals 0. I'm going to go ahead and graph that in right away. Scroll down a little bit. All right. So the next thing I want to do is figure out what my x-intercepts are. Or actually, just wait a second. I graphed x equals 0. My bad. Oh, can't do that. Okay, let's fix that. Y equals 0. So that's actually just my x-axis. Okay, so for my x-intercepts, I'm sure you guys can guess, since our asymptote is on the x-axis, that we probably aren't going to have one. But just to show that, we could set y as 0 equals 4 over x squared plus 2. If I was to multiply my denominator to the other side, that would give me 0 equals 4, which is not a true statement. So in the end, we are not going to have an x-intercept. For my y-intercept, I'm going to set x as 0. So y equals 4 over 0 squared plus 2. And I could simplify this as 4 over 2, which is just 2. So my x-intercept, written as an ordered pair, would be 0 and 2, which could be like the center point of my table that I'm going to make next. So once again, domain and range, I do think it's easiest to identify it once we've graphed. So now let's go ahead and create our table. Okay, I'm going to have 0 and 2 as the center point on our table. And I'll just create a couple points on both sides. So maybe I'll do -1 and -2, and 1 and +2. That should be enough. So now I'll substitute these into our function. So -2 squared is 4, plus 2 is 6. That will give me 4 over 6, which can be written as 2/3. -1, 1 plus 2 is 3. So that's going to give me 4/3. And actually, since we have x squared in our denominator, we are going to be the same in the positive direction. Okay, now I'm going to go ahead and graph these points. So I'll actually start with 0 and 2, since that's my starting point. -1 and 4/3, so 1 and 1/3. And then I've got 2/3, and the same thing on the other side. And that's going to give me a graph that looks something like this. which is a little different than what we were looking at in the last lesson. So from here, my domain, as I head in the negative direction, continues forever. Same goes with the positive direction. So that's going to give me a domain of all real numbers, or you could write negative infinity to infinity. For my range, on the other hand, this is a little bit odd. So as I head in the positive direction, the max point I'm going to have is at 2 here, because as it goes in the negative and positive x directions, I'm just approaching 0. So 2 is actually going to be my maximum point. My minimum, though, my asymptote is at 0. So my minimum is actually at 0, but I have to use an open bracket for that, since 0 can't actually be contained in my function. So that's my domain and range for this one. All right, let's look at one more example, and then we'll save the other one for class. So in this example, things act very similarly. The only thing that's a little bit different is that my denominator can actually be factored for this one. So when rewriting this, I'm not going to do anything to my numerator since it's already written as an exponent, but I do think I want to factor my denominator since it is a difference of squares. By factoring this, that'll allow me to find my zeros much easier for my vertical asymptote. So x squared minus 1, difference of squares, factors as x plus 1 times x minus 1. So like I said, for the vertical asymptote, we are trying to figure out what values can I substitute in for x in order to make my denominator 0. So my zeros are just my two factors. So I can write x plus 1 equals 0, and that's going to give me x equals negative 1, and x minus 1 equals 0. And that's going to give me x equals positive 1. So those are going to be my two vertical asymptotes for this case. So if your denominator is factorable, there is a chance that you will have multiple vertical asymptotes. So I'm going to graph both of these in actually. X equals 1 and x equals negative 1. All right, now my horizontal asymptote. So in this case, referring to my table in the last lesson, both of my exponents are equal to each other. So that means that we have to refer to our leading coefficients. So remember, it's a fraction with the leading coefficient of your numerator over the leading coefficient of your denominator. So the leading coefficient of my numerator is 3. Leading coefficient of my denominator is 1. 3 over 1 can just be rewritten as 3. So my horizontal asymptote is actually at y equals 3. So I'll graph that in as well. So in this case, I have a lot of asymptotes. So I might as well go and try to find my x and y intercepts now. So for my y-intercepts, I'm going to substitute in 0 for y, or f of x. 0 equals 3x squared over x squared minus 1. So the only x value that's truly going to give me 0 in this case would just be 0, because then I would have 0 over whatever my denominator is. So actually my x-intercept in this case is just 0, 0. My y-intercept, y equals 3 to the 0 power, or 3 times 0 squared over 0 squared minus 1. Well, all of this is just going to equal 0 right away. So that's just going to give me y equals 0. So once again, my y-intercept is also 0, 0. So I know I'm going to have a point at the origin here. All right, so now let's go ahead and create our table. So for our table on this one, it's a little bit tricky because we do have a lot going on. So I want to choose a couple values that are on the left side of my asymptote, a couple values that are inside my vertical asymptotes, and a couple values that are on my right side. So picking values here, I might choose -3 and -2, since those will be on my left. Maybe I'll do -1/2 and +1/2, since those will be in between. I already know my origin here. And then maybe I'll do 2 and 3 because that is on my right side. So substituting in -3, I'm going to use a calculator for this one. That's going to give me 3.375. Be super careful with parentheses, especially when you are squaring a negative number in your calculator. -2 is going to give me +4. -1/2 is going to give me -1. Same goes with +1/2. 2 is the same as -2, and 3 is the same as -3. So be super careful. Take your time when constructing these tables. So now I'm going to go ahead, plot my points. -2, -4, -3, 3.3. So that kind of concludes my right side here. In my center, -1/2, -1. It's going to give me a parabola-like shape. And then on my right side, I've got -2, +2, +4, 3, 3.3. It's just going to look the opposite of my left side. Okay, sorry these graphs aren't the neatest. I'm trying my best with my pen here. So now let's take a look at our domain. So in our x values, really the only places that our function is undefined is at our two vertical asymptotes. So once again, I'm going to write my domain as all real numbers, but I do need to state my restrictions. So in this case, x cannot equal +1 or -1. So I'm just going to rewrite that as ± 1, because that includes both of those two values. For our range, on the other hand, I cannot have any values on my my horizontal asymptote, but it also looks like I don't have any values above 0 here. So I'm going to write my range as interval notation, because in the negative direction I have values, so -∞, but that really stops right up here at the top of this parabola, which would be at 0. But then once again, it resumes after my value of 3. So I can't actually have 3, so I'm going to use an open bracket, but it does continue in the positive direction. So it does continue to positive infinity. And really, I shouldn't just use a comma here. I should use my and symbol instead. My bad there. So as you guys can tell, once we get to these more complex rational functions, there is a lot more to consider, especially when it comes to the domain and range. So make sure that you guys are taking your time and really relearning that concept once again. All right, please try this third one on your own. See if you can navigate how to go about solving an example like this, but we'll make sure to take a look at it during class together. All right, thanks for watching.